Alright, so there's two more growth and growth models, not really decay growth, and they deal with interest rate. So here we have one formula, and then we're going to have one more dealing with E. So they just rename a couple of things. So right here, the P, that's called your principal amount, which again, that's just your starting number. So when they say your principal, that's your initial amount. So however much money you deposit in the bank. Here we're still going to have 1. Here R is still going to be the rate given as a percent. You need to change it to a decimal. T is still time in years. The only difference is that these have n's. So here you're going to have an n in the denominator, and you're going to have an n in the exponent. This stands for the compounded n times a year. So the number of times it's compounded in a year. So compounded means the number of times or how often the bank takes your money, multiplies it by the interest rate, and adds to your account. So there's going to be several words. We're going to talk about all of them at once, and then we'll come back and do these individually. Okay, so I'm going to skip to an example that has all the possible compounded times. Not all the possible ones, but the ones that we see most often. So here in example 10, it says you place $2,200 in a savings account. Find the balance after 4 years for the following situations if the interest rate was 3%. So here, these are the values of n. So all of these talk about the number of times it's compounded in a year. But let's do, see that one, let's do that one. I'm going to need one for daily. Let's set up the equation real quick. So the formula is A equals P times 1 plus R over N to the NT power. Okay, so getting all the values here, P is your starting amount. So we started with 2,200. R is the interest rate. So here it says 3%. So if we change 3% to a decimal, we get 0.03. And we want to know how much is in the bank after 4 years. So 4 is our time. So that's going to be our exponent. So for the n's, for both of these, the denominator here and the exponent here, we're going to use these values for the number of times it's compounded in a year. So annually means it's compounded 1 time a year. At the very end of the year, they take your money, they multiply by the interest rate, and then they add to it. Semi-annually means they compound it twice a year. So in July, they take your money, multiply it, and add, and then in December again. Quarterly means 4 times a year. So every 3 months they'll compound it, but total it's 4 times a year. Monthly, at the end of each month, they compound it, which would be 12 times a year. Weekly, we say about 52 times a year. And daily, we'll just stick with 365. Okay, so we're going to use the formula to find A for all of these. A equals, and then we do P, so P's first, the 2,200. 2,200 times 1 plus R is 0.03. 1.03. I just want to do the point there. divided by n, which n for annually is 1 time. And then we raise it to the n times t power. So n is 1 times t is 4. So we're going to do this for all of these situations. So over here, we'll go ahead and find this one first, and then we'll go and find the other ones. So let me erase the formula. In the calculator, we're going to do 22, menu calculator, 2200 times 1 plus the fraction here, so control divide is the fraction sign, 0.03 to the, 0.03, I don't need that parentheses there, divided by 1, get out of there, so close your parentheses, and then do your exponent, and you're going to multiply both of these together in the exponent, so 4 times 1, which is 4, but 4 times 1 times 1. And we get that this rounded to the nearest cent, because there's 2 decimals. We want pennies, so we say there's $2,476.12 in your account after 4 years. Okay, so it gained however much, that is from the 2,200, the $276. Okay, so we're going to do the same thing for all of these values for semi-annually, quarterly, monthly, weekly, and daily. Okay, so I'll do one more in color, and then I'm just going to write the whole thing out. So here we're just going to do 2,200, that's our P, times 1 plus R is still the 0.03. Now this time we're going to divide it by 2, because semi-annually is twice a year, and we're going to raise it to the 2 times 4 power. So 2 times 4 is still the time. Okay, so let's see what this one's going to be when we type it in. So this one approximately, and these are rounded here. These values are going to be rounded in the calculator. So if you don't want to type the whole thing over again, if you just go up and you highlight this one, you press enter, it'll copy it, and then all you got to go do is change the number. So go to the 1 and change this one to 2. Make sure you change both of them, the exponent and the denominator here. So delete 2. And we get, this one is $2,478.28. Okay, so this one, I'm going to plug in 4s. So 2,200 times 1 plus 0.03 divided by 4 to the 4 times 4 power. This one, I'm going to plug in 12. 1 plus 0.03 divided by 12, because it's monthly. 12 times 4. Weekly is 52. 1 plus 0.03. Divided by 52 this time for weekly. And it's 52 times 4. And then daily. So 365 to the 365 times 4 power. So here, you would expect to get more money because you're compounding it more often, and you do get more money, but it's not a lot more. Okay, it's a few more cents in the last few cases. Here, it's a few more dollars, but eventually it's just a few more cents. So getting all those values, that one, so go and change the 2 to a 4 for the quarterly one. So 4 and 4. And here we get $2,479.38. And then we do 12, 52, So enter. Oopsies. So 0.03 divided by 12. So $2,480.12. So it's going up, but again, it's not like it's hundreds and thousands of dollars more. It's a couple of dollars more. So here, we'll do the 52 for the weekly, and then come down here and do the 52. Make sure you change both. There's always two ends in the formula, so change both of the ends. So for the weekly, it's $2,480.41. So again, this one's not even dollars difference, it's just cents difference. And then finally, we have daily. So the 52 becomes 365. And I mean 366, if you do the leap year, it's not going to change it very much. So 365. So here, $2,480.48. So in the end, it's only 7 cents difference. So I mean, this is your bank account. You want to get it compounded more often. But I mean, especially if it's compared to once a year. But I mean, it's not going to be that much difference if you do, monthly versus daily. But what if you wanted to do minutely, or what if you wanted to do every second of the day? It's going to cap off at a certain time, and that gets us into the last formula. So we'll prove why this works next time. But if, let's say, you compound it every minute of the day, or every second of the day. How many minutes are there in a year? How many seconds are there in a year? If you look at the formula, it's P1 plus R divided by N to the NT power. The N here, if it's, hourly, that's however many hours there are in a second, or in a year, sorry. However many hours there are in a year. So you can put that number. But again, it's not going to be much different than what we just had with the daily. You can do every minute. You can do every second. You can make these be as big as numbers you want. But we really can't type in the biggest number, which is infinity. So if you want to think of it that way, if you type in infinity here, that means it's compounding every moment. Every minute of every second of every day, it's compounding. At that point, we say it's compounding continuously, and we use this number E. Instead of plugging in infinities here and plugging in really big numbers, we just use E, which is the number 2.71828. I'll put one more. That just means it's all the time. It's compounded every second of the year. But everything else is the same. So the P here is still the initial amount. The R is now part of the exponent, but it's still your rate as a percent. You have to change it to a decimal. And T is still the time. Okay, so when the instructions don't say, or when the word problem doesn't say like how often, like monthly or annually or daily, if it says continuously, that means it's all the time. So then you can't plug in infinity, but you use E because that's the number that it's going to get closer to. It's called a limit, and like I said, we'll prove it next time. But right now, I just want you to show, I want you to see how it works. So here you deposit $3,500, that's your initial amount, into an account that pays 4% is your rate, so 0.04. is your rate. And here it says it's compounded continuously. This tells us that we're going to use E, the number E, and I'll show you how to get that in the calculator. Oops, sorry, I put the rate for the wrong number. The rate is 0.04, and we want to know how long or how much is in there after 5 years. So 5 is your T. Alright, so A equals the principal amount is $3,500. It's compounded continuously, so we're going to use the E, so 3,500 times E, and in the exponent we're going to multiply the R and the T. So multiply 0.04 times 5. And again, we're still dealing with money, so we're still going to round to the nearest cent. So here we do 3,500. And then E is this e to the x right here. You can use this one and plug in, so it automatically gives you the exponent, which is 0.04 times 5. So you can multiply those together in the exponent. And we get that there is $4,274.91 after the 5 years. So again, the keyword for this one is continuously. There's another way, there's a few ways to get the E, but you'll also see on the little pi sign, if you click the little arrow, it gives you, because all these numbers, pi is irrational, it's the decimal repeating, and so is E. So here, again, this gives you the decimal 2.71828. You can think of it as 2.7 just in your head, but if you don't have access to the E button, then you need to keep 3 or at least 4 decimals without rounding it. 2.7 is rounding too much because your answer needs to be accurate to 2 decimals. So if you round it too much here, then that's going to change what this answer is here. So just be careful with that. I would keep all the decimals without rounding until the very end. I would leave them all in the calculator. Alright, so let's do one more with this, and then those are the 4 models. The rest of it is just practicing with the 4 models. Alright, so you deposit $4,800. So again, that's my P, my initial amount, into an account that pays 6.5. So if we move it twice, we get 0.065 as your rate. And it's compounded continuously. This means we want to use the E. I call it PERT. We want to use the PERT equation. And I want to know what is the balance after 3 years. So 3 is my time. So A equals 4,800 times E, oops, because it's continuously, we're going to multiply that by the E to these two things multiplied together in the exponent. 0.065 times 3. And this one is probably just to type the whole thing in and not do the copy paste. You can do the copy paste if you want, but it's not that much work to type it in. 0.065 times 3. And we get that we have $5,833.49. Okay, so the last few problems, I'm going to go back and do the ones that I skipped, but those are the 4 models. You got to be able to use those models to answer any growth or decay questions. Okay, so going back to the ones I skipped, and then I'll come do 16 here. So number 8 says you deposit $2,900 in an account that pays 3.5% annual interest. So $2,900. Here's your P. R is 3.5, which as a decimal would be 0.035. Again, you just take this 3.5 and divide it by 100. That's what this little percent sign means. Divide by 100. T, we want to know after 5 years. And then it says it's compounded annually and then monthly. So this one, we're not going to use the E one, we're going to use the NT one. So N for annually is once a year, and N for monthly is 12 times a year. So again, the formula was P times 1 plus R divided by N to the NT power. So P is 2,900. I'm going to go ahead and write it for this one too because it's the same starting amount. Times 1 plus R divided by N. So R, the rate, was 0.035. 0.035. And then for annually, I'm going to divide it by 1. For monthly, I'm going to divide it by 12. And again, technically you don't need the 1, but I mean, you're going to have to use the formula twice, so I'm just going to leave it there. Okay, and in the exponent, we're going to multiply the N and the time, which is 5 years. So multiply it by 5, multiply by 5. And then we just go type these in the calculator. So 2,900 times 1 plus, and I'm doing controlled divide here to get the fraction sign, 0.035 over 1 for the first one for part A. Close it and do the exponent, and we're going to multiply 1 times 5 in the exponent. And we get that decimal. And I'll come write it in just a second, but let me go ahead and get the other one. Oops. So enter. And then change the 1 to 12 for monthly. And then change this one to 12. Okay, so for A, if I compound it once a year, I end up with $3,444.29. If I compound it 12 times a year, I get $3,453.73. So just a little bit more. But again, if you had the choice, compound more often than not. Alright, and then we have a similar one with quarterly and daily. So again, you deposit 4,000, so 4,000 is our starting amount. 4,000 is the starting. Times 1 plus, we need R and N. So R, 2.92 if I move it over twice. If I divide by 100, I get 0.0292. So this is going to be 0.0292. 0.0292. And then we have N at the bottom. So N for quarterly. How many quarters are there in a year? There's 4 quarters in a year. So 4 is here. And it's the exponent as well. Daily, how many days are there in a year? Again, we're just going to use a regular year. It's not going to change it much if you do 366. 365 here and 365 here. And we want to know how much money is in there after 5 years. So our T is 5. So times 5 times 5. So 4,000 times 1 plus control divide R, oops, control divide. R was 0.0292 over quarterly is 4 times a year. And we're going to do to the 4 times 5 power. I mean, you can put 20, because I know what 4 times 5 is. But here, if I do Control Enter, oops, I'm going to go highlight it first. Highlight Enter. Then it's just easier for me to change this number without having to figure out what that new exponent is. So 365. And then come over here and change this one to 365. And those are 2. So for the quarterly one, we get $4,629.33. And for daily, $4,628.76. Okay, so with these calculators, I mean, they already round for you to 2 decimals. With the other ones, if they give you more than 2 decimals, just make sure you round to the nearest cent for your final answer. Okay, and then we have one more on the PERT part, and this is going to be the solving. So come back over here. So here you deposit $700 in an account that pays 2.75% annual interest. How long does it take for the balance to reach $2,000 when the interest is compounded continuously? So notice the difference for this one. So I still give you the starting $700. It says continuously, so I know I'm going to use E. And it gives me the rate, which as a decimal, I'm going to do 0.0275. But it wants to know how long. So we're looking for the time. I'm going to put X for the time here. We want to know how long does it take for it to reach this much. So that's what we want it to be equal to here. So this is a solving problem, which again, we don't know how to solve this by hand yet. We only know how to do it in the calculator. So the window that I'm giving you, so this is T. This actually goes not by 1s to 10. It starts at 0 and it goes to 50. So it's counting by 5s. But really we just need the min and the max. And then here, this is 700. So this one starts, this is 500, this would be 1,000, 15, 20, 25, all the way to 3,000. So 1,000, 2,000, 3,000. So we want to know, so here's the function, here's this function right here. At what time do they intersect? So what is this value on the graph? So this one, we kind of have to find the intersection because these don't go by 1s. We can't just say that this is, you know, closer to one or the other. These are by 5s. So we have to go find the intersection for this one for sure. All right, so we need a graph. So doc and oops, escape. So new, yes, and I want a graph. So remember how we did this with the other ones? We type in the equation into y1, 700, e to the 0.0275, and we want the x in the exponent. Enter. We're not going to see it because, I mean, this goes all the way to 50. But we tabbed, put the other one in. We want to know when is it going to be equal to 2,000. And I'm not going to see this in this window, so this is definitely one where you want to go change your window. So go to Window, Settings, 0 to 50 here. Usually it was 0 to 10, but this one's going to take a long time, so This one's going to be 0, and then the highest number is 3,000. And we'll be able to see them. Oh, where did the other one go? That was my mistake here. I put a 7,000 instead of 700. So if I do 700, there we go. There's our graphs. So here is the line, here's the equation. Remember how we find the intersection here? You go to Menu, and then you go to Analyze, and we want the intersection. So just to the left of it, and then to the right. So again, we go a little bit to the left, a little bit to the right, and it's saying that this point is 38.2, comma, some 2000 number, but I don't care about the y. So the x value, we can say that time is about 38 years. Because we just rounded the nearest whole one. But here, again, the intersection you would need, because you wouldn't be able to tell, knowing that these count by fives, you know, whether that's 38, 37, the intersection is required for this one, whereas the other ones, when it was the nearest whole number and it only went to 10, you really didn't need it. Okay, so those are our 4 models. It's up to you to decide which one to use in the situation and then actually plug in the numbers. So we'll talk about the E number next time.